Hello everyone, welcome back to my construction vlog. Today, I'll take you from the blueprint all the way to the realistic 3D images of the house I'm currently building. On the screen, this is the 3D model of the project. And if everything goes according to plan, the house will eventually look just like this. Beautiful and impressive, right? In the previous part, we finished setting up the columns and the formwork for the first floor roof. Now, let's take a look at the results. Now, let's move on to the next stage, the process of installing the steel for the first floor roof. Let's go! To start, we see the skilled worker using specialized tools to bend the end of steel bars at a 90-degree angle. This bending creates an anchor, allowing the steel to connect firmly with other bars in the structure, ensuring the beam's strength and stability. Next, the bent steel bars are positioned to form hooks connecting the two beam steel frames. The installation is carried out according to the design drawings, ensuring correct spacing, positions, and lap length according to technical standards. One end of the steel is pre-bent, while the other is measured and adjusted according to actual dimensions before bending, so it fits perfectly within the beam structure. Then, the main steel bars are tied to the reinforced columns with wire, creating a strong link between the beams and column system, ensuring the overall structural strength and stability. The steel bars are secured at the ends and middle of the beam formwork, usually at 1/3 spans, facilitating the threading of D8 or D10 stirrups and fixing the formwork. Methodical. This arrangement ensures the beam stays in place, accurately carries loads, and aligns with the design. Next, the worker threads the stirrups around the main bars. The spacing is usually 20 to 30 centimeters, depending on the beam span. This step ensures the lower steel layer stays in position, keeping the beam stable when pouring concrete. Once the stirrups are in place, the worker ties them with wire and twists the joints tightly using specialized tools. This makes the steel system sturdy and ready for the concrete pouring stage. Depending on the size and quantity of steel, manual or electric cutters are used. It's crucial to cut straight, to the correct size, without deforming the steel and ensure absolute safety. Gloves and glasses are a must. After cutting, the steel bars are carefully transported to the site. Then, the bars are positioned according to the design drawings, ready for precise installation within the structure. Now, let's return to tying the stirrups. Twist consecutively and tighten each joint to ensure the stirrups stay in place and the beam becomes stronger. To achieve optimal beam strength, 3 long steel bars are placed on the top and bottom of the beam formwork, evenly spaced according to the design. Continuing with the steel bending process, the main tensile bar at midspan must be bent precisely according to the drawings. Each beam span has a different curvature and radius, ensuring the bar fits perfectly in the formwork and optimizes load bearing. You can see stirrups being threaded onto the main bars. These stirrups, usually D8 or D10, are bent into loops, rectangles, or U-shapes, wrapping around the main bars to secure and stabilize them. Meanwhile, another worker bends steel for the next beam, ensuring every bar has the right size and curvature. The steel bars are cut into predetermined lengths. For long bars, multiple pieces can be cut at once, but safety must always be ensured. Wear gloves and safety glasses to avoid sparks hitting anyone. The bars threaded through the beam are called distribution steel. They hold the main bars in position and help distribute forces evenly in the concrete, ensuring a strong and effective beam structure. Now, we install the lower steel layer. The main steel is laid in 2 directions, longitudinal and transverse, ensuring spacing according to technical drawings. Typically 150 millimeters for longitudinal bars and 200 millimeters for transverse bars. Preparing the upper steel layer. This is the negative moment steel, crucial for better floor load bearing and resisting bending at beam edges. The upper layer is placed perpendicular to the lower layer, according to design spacing and positions. Before threading the steel, the worker carefully measures each position to mark the paths for the wires and bars. This step is crucial. It keeps the 2 steel layers aligned, ensures spacing and positions according to the design, and maintains the correct concrete height. After threading the steel, we tie the final knots to prevent movement. This step is very important. It ensures the steel is fully covered when pouring concrete, does not slip or shift, and helps the floor remain strong and load-bearing as designed. Small steel bars are bent 90 degrees at the ends to anchor the steel, increasing connections between bars and enhancing the floor's load-bearing capacity. This detail also makes it easier to tie stirrups or anchor steel layers, ensuring no movement during concrete pouring. After placing the main bars and bent bars, we tie the steel with soft wire. Each knot must be twisted firmly, with enough force but without deforming the bars, to secure them in place and prevent movement during concrete pouring. Twist 2 to 3 turns around the intersection of main and stirrup bars. Work quickly and evenly, avoiding tearing the wire or shifting the bars. Check the height of the lower and upper steel layers, ensuring they don't touch the formwork, and maintain the correct design height. This tying and twisting step, though small, is extremely important because it ensures the concrete floor is strong, the steel is fully covered, and loads are carried accurately according to technical drawings. Now, let's return to beam work. First is placing the main beam steel, including positive moment steel at the bottom and negative moment steel at the top, according to the spacing and diameter in the technical drawings. The stirrups and anchor bars are threaded alternately and tied tightly, ensuring the steel does not directly touch the formwork, thanks to precise spacers. Threading the steel layers continues for the remaining parts of the floor. Tying, twisting, and placing bent bars are carefully done. Although repetitive, these steps are crucial to ensure the concrete floor will be strong and load-bearing as designed. One person ties the steel layers, ensuring the bars maintain the correct spacing and design height. Another person twists and secures the beam stirrups, making sure the joints are solid and the steel does not shift during concrete pouring. This clear division of labor makes the work faster, more precise, and also ensures the quality of the entire floor and beams. Although the work is repetitive, each action is crucial for the structural integrity and load-bearing capacity of the construction. So the process of installing the first floor roof steel is now complete. From laying the lower steel layer, placing the upper layer, marking, threading, tying and twisting bent bars, to securing the stirrups, everything is done according to the design drawings and technical specifications. This ensures the floor and beams are firmly connected, the positive and negative moments are transmitted accurately, and everything is ready for the next concrete pouring stage. The journey of building this house is still long and full of challenges, but also many exciting moments ahead. If you're building a house or love construction, continue to follow along in the upcoming vlogs. Thanks for watching, and see you again.